discuss this topic, locus. Locus of points is, part of coordinate geometry that I couldn't finish last time. Coordinate geometry 1, we have done part 1, we have done part 2, and this is part 3. So part 3, I'll be teaching you on locus of points. So now, locus of points are an interesting topic for those preparing for JAM, especially, and also WAEC. You get, so you have to pay attention as I teach you. Now, whenever you hear the word locus, think of set of points. Set of points. So I can define locus as set of points which satisfy a given condition or rule. And those conditions or rules are what we call theorems of locus. So I will be discussing the theorems of locus right now, and I start. Theorem 1. Theorem 1. Theorem 1 states that locus of a point which move such that its distance from a fixed point is constant must be a circle. Now, this is the fixed point. Call it O. This is the locus. Call it P. This locus of points begin to move. Begin to move. Begin to move. What are we saying? We are saying that the distance here is maintained. The distance is what? Is maintained, is constant, is the same. And if here is O, and here is what? P. It also means that OP is equal to radius of the circle formed. Right? Now, next theorem. Theorem 2. Theorem 2 is saying that locus of points equidistant from two fixed points is a perpendicular bisector of the line joining the points. Now, let's make a diagram here. Alright, here is the fixed point. This is the two fixed points. This is fixed point. Now this is A, and this is what? B. Right? Now the locus equidistant from these 2 points must be a perpendicular bisector. This is the line, right? It must be a perpendicular bisector of this particular line AB, right? Yeah. And this one perpendicular bisector, right? And the perpendicular is to make what? Angle 90, right? And in such a case, let us use B, locus. In such a case, AB must be equal to BP. Don't forget it. Very, very important. Now, next theorem. Call it theorem 3. Now, theorem 3 is saying that locus of points equidistant from two, intersecting lines is a pair of angle bisector of the angle formed by the lines. For instance, now let's make a sketch. Now this is the first line. Call it P. Call this one Q. This is the next line. Then intersect here. Call it what? R and S. Now locus must be a pair of angle bisector of the angle, formed by the lines, and this will be the locus. And also this is what? The locus. In that case now, it can form what? It can also form a circle, right? Alright, now knowledge of this will help you by the time we'll be solving jam past questions. You understand how to apply all these theorems. Understand? Now next one, theorem what? Theorem 4. Theorem 4 is saying that the locus of points equidistant from two parallel lines or two straight lines is a line parallel to those lines and midway between them. So now let's make a sketch of diagram now. Now this is two straight line. This is a straight line. AB. This is another straight line. B. This AB. and this is C, D, right? Now, these are parallel lines. What are we saying? We're saying that locus of point equidistant from these two parallel lines is a line parallel to both line and as well midway between them, meaning that it will be at the center of the line. Let's call it what? BQ. So BQ is what now? Is the locus of these two straight line. Alright, now is midway between them in the sense that the length here or the distance here is always maintained. Is equal. Are you following me now? That is called locus of point. Now, the next theorem. The next theorem is saying that what is theorem? Theorem what now? Theorem 5. It's saying that the locus of point equidistant from a given straight line is a line parallel to the line given, and in such a case the equation of the locus and that of the given line they must have the same coefficient of x and y but different constant. Now I'll show you a jam pass question where they ask you this particular one I just made mention now. Now let's make a sketch of this theory 5. This is the given line. Call it what? AB. What are we saying? We are saying that a locus of point equidistant from a given straight line is a line parallel to the given line. So which means this will be a locus. Let's use broken line to draw it. This must be a locus because it is also parallel to this straight line, right? And what are we saying is that in terms of equation, the equation of this locus of points, you get, and the equation of given straight line, they must have the same coefficient of x and y, right? All right, but the constant varies. They don't have the same constant. All right, now the next theory, I think that is the theory I have to explain for now. Let's drop to 25. Now, the next thing now is that we shall be talking about what? Past questions. So I'll be telling you, revealing to you the question, jam past question, and so that you know how to apply each of the theory. So let's go back to jam past question. Let's start with this question. This is jam past question, right? Now, question 1 says the locus of points at a given distance from a point x is dash. This is 2024 question number 6. Now, option A, angle bisector. Now, look up, understand the question first. It is not angle bisector because we don't have two intersecting lines. So the locus cannot be angle bisector, right? Nor be perpendicular. It can't be perpendicular because we don't have two fixed points where the locus will bisect the line join the point. So it's not. Now, option C, a circle with radius. Now, this option C cannot be considered. Reason being that the question does not give us radius. The question says a locus of point at a given distance from a point x. So they don't give us radius. Now, option D, a circle with center x, and it must be option D because that locus of point equidistant from a fixed point, and the point has the center of x. So option D is correct. Next question. Next number. The locus of point equidistant from two given points. Note, two given points is dash. Option A, parallel bisector of the distance between the points. It can't be parallel bisector. It can't parallel because there are two fixed points. So the locus cannot be parallel bisector, right? No, it can't be. Now option B, perpendicular bisector of the distance between the points. Like I told you when I was listing the theorems, I said for two fixed points, the locus of point was what? A perpendicular bisector of the line between the points. So option B is correct. Next question. Let's solve the next question. Find the equation of the locus of a point A having the coordinate x, y, which is equidistant from point B having this coordinate and point C having this coordinate. Now, these are the options. This is the JAMB question 2016, question number 17. Now, look up. Very important. I gave you a theory, right? I say that locus of point equidistant from two fixed points is always a perpendicular bisector of the line join the point. And in such a case, I make mention of, I wrote something like AP being equal to what? B what? BP, right? Now, these are two fixed points, B and C. Then this point is this. This is B, this is C. So this is the line, this is the locus. Now they are asking us to find the equation of this particular locus. Where I told you to get the equation of the locus, it means that B, locus is what? A, right? B, A, B, right? Must be equal to what? A, C. That is, the pattern you use to solve the equation of what? The locus. Now, so we are solving our solution. Okay, now in part 1, under this topic, I taught you how to find a distance between 2 points on a straight line, right? And then, which I gave you the formula for that. We are going to apply that formula to solve here. Now, what I'm going to do now, the distance between point A and point B is always given like this. Now, point A has the coordinate what? X, y. Point B has the coordinate what? Let me just write again here. So A has the coordinate x, y. B has the coordinate o, 2. Right? So now, to get the distance between A, B, you have to apply the distance formula. And that should be square root of, now, x2 minus x1 all square plus y2 minus y1 all square. Now, so this is the distance. The formula to get the distance between what? Point A and point B for this one. And that must be equal to, now consider this one again. AC are another 2 points. Alright, so the distance between AC. Now for AC, A has the coordinate x, y, and C has the coordinate 2, 1. You still apply the same formula here. So that will be square root of x2 minus x1 all square plus y2 minus y1 all square. Now, at this point, we are going to substitute the variable. Now, look up here. For AB, remember, A has the coordinate this, right? Yes. And B has the coordinate this. Now, let me write again so that you understand. For AB, this is A, x, y, B, 0, 2. Okay, which means A comes first, right? Yeah. It means that A has what? x1, y1. YB has x2, y2. Then go back to part 1 and watch that part so that you understand this one. Alright, now I'm going to substitute now. So x2 is what? x2 now is 0. Because point B has coordinate x2, y2. Point A comes first, so it has the coordinate y1, y2. Which means our x2 here is 0, right? So I'll write 0 minus x1 is x. So I'll write x. Then all square plus y2. y2 is 2. So I'll write 2 minus y1 is y. So I'll write y square. Remember to put a what? Your square root equal to. Now this is the next point, which is what? AC. Now for AC, the first coordinate x1, y1, second coordinate x2, y2, right? Yeah. So I want to substitute now. So we have our x2 is what now? Is 2, right? Yeah. I write 2 minus x1 is x. So I write x square plus y2 is 1. So I write 1 minus y1 is y. I write y all square. I remember to put your square root. So at this point, I'm going to expand. So I have this implies 0 minus x is still giving me what? Minus x, right? Yeah. Then put a what? Your square, right? That is minus x square. Then plus 2 minus y cannot minus, so you have to simplify, and that will be, you don't have to expand now, you expand the equation. That will be 2 power 2 is 4 minus 2 times 2 4, then put a y, 4y, then plus y squared. If you don't know this method, just use the usual way of expansion to get the same thing, right? Now equal to, remember square root is here, equal to, okay, this one the same thing. You cannot subtract, we expand, so this will be 4 minus, this is 4x, and this is a plus x squared. Okay, now plus the same thing here, this is 1 minus this is 2y, then plus y squared, right? Yeah. Put your square root. So now we say minus x times minus x will still give you what? X squared. So we have what? X squared, then plus 4 minus 4y plus y squared equal to square root of, remember all of the square root. This one should be 1 plus 4 plus 1 is what? Is 5 minus 4x plus x squared minus 2y plus y squared, right? Yeah. Then what we'll do here, you take the square of both sides to remove the square root. Take the square of what? Both sides. So square both sides. This cancel, this cancel. So what happens is what? X squared minus plus 4 minus 4y plus y squared equal to 5 minus 4x plus x squared minus 2y plus y squared. Now at this point you can collect like them, right? Yeah. Now we have x squared is here and the x squared is here. You see now, so I'm going to have x squared. This one is going inside because minus what? X squared. Are you following me now? Yeah. Then plus y squared is here. Y squared is here. Let me write it very well. This x squared. This is plus y squared. Now this y squared is coming this side because minus what? Y squared. Alright, now we have what again? So we have minus y is here, 4y is here. Okay, then minus 2y is called becomes plus what? 2y, right? Yeah. Then minus 4x, we go this side because what? Plus what? 4x, right? Yeah. Then equal to, I want number to be this side. So 5 is here already. Okay. Then 4 is going to meet 5 because minus 4. Are you with me now? Yeah. Alright, now this can cancel. This cancel. Minus 4 plus 2y is what? Minus 4y plus 2y is minus 2y plus 4x equal to 5 minus 4 is what? Is 1. Now look up. I want to write 1 first. So I'll write what? 4x minus 2y equal to 1 equal, and that is where I'm going to stop. This is the answer. Which option has this thing? Option C. Option C is the correct answer. Next question. Let's look at this question. Number 4. The locus of a dog tethered to a pole with a rope of 4 meters is a dash. Now, this is, the pole, right? Now, this is the rope, right? And this is the dog. Don't mind my diagram. This is the dog, right? Now, let's look at the question now. The locus of a dog tethered to a pole with a rope of 4 meters. So this is what? 4 meters is a dash. A semi-circle with diameter 4 meters. It can't be semi-circle. So it can't be. So it's not. B semi-circle with radius 4 meters. It can't be semi-circle. It can't be. C circle with diameter 4 meters. Look up now. If this thing begin to move, maybe if you touch this dog, the dog can begin to move. When the dog is moving, how will it move? Moving around like it's moving around. And what now? So if the dog moves around, now the length of the rope cannot be the diameter. So it is not C. Now D circle with radius C meter, with radius 4 meters. So a circle with the radius 4 meters is the answer. So D is correct. Next question. Next question. The locus of a point equidistant from the intersection of lines 3x minus 7y plus y equal to 0 and 4x minus 6y plus 1 equal to 0 is a dash. A line parallel to 7x plus 31 plus 8 equal to 0. It can't be a line parallel. Now let's consider. You see that the two lines intersect. I gave you this theory. Locus of point equidistant from the intersection of two lines. Alright, they say one. It will be what? That is parallel. Line parallel to this. It can't be parallel. B circle. Now let's leave B. We'll come back to B. C. It can't be semicircle. D. Bisector of the line. It can't be bisector of the line. So it must be. We say that is a pair of angle bisector of the angle formed by lines. Where I do something like this, and I told you that because of this, it's good for that the locus will do what? Will form a circle. So the correct option is B. B is correct. Next question. Let's solve next question. What's the locus of points equidistant from the AX plus BY plus, this is BY plus C equal to 0, right? Now, these are the options. Now look up. When it's the locus of a point, equidistant from this thing is one line. One line. I told you from the theory that locus of points equidistant from a given straight line must be a line parallel to that given line. And I gave you something, I told you something that in such a case, the equation of that locus of points and the given line must have the same coefficient of x and y, but different constant. Now watch this option now. A line, that is A option. AX plus BY plus Q. Watch. A is the coefficient of x. Is same thing. A is same thing, right? Yes. Addition is maintained. Then B is the coefficient of y is maintained. Then Q is the constant, which is not C. Right? Apart from this, other ones is not correct. So option A is correct option. Next question. Next number, let's solve. Now the question says, if the locus of points which are equidistant from P and Q meets a line PQ at N, then Pn equals that. Let's just make a sketch. Now this is P, this is Q, this is Q, this is P. It says the locus of points which are equidistant from P and Q, which means I have to join this line, right? Yes. Then meet line PQ at where? At N. Call this thing N, right? So this is the locus. Now they say then P N, which is this, P N equals dash A half of NQ. It can be half of NQ. B 2 times NQ is not. C 1/4 of NQ is not. D NQ, which I have told you that PN must equal to what? NQ, which is option D. Next question. Let's solve the last question. It says, find the locus of points equidistant from two straight lines. Y minus 5 equal to 0 and y minus 3 equal to 0. These are the options. Now, I told you something about locus of point between two straight lines. I said that it must be a line midway between them, meaning that if these are the lines, right, the straight line, the locus must be the line midway between them, and it also must be parallel to the two lines. Now, the first line is y minus 5 equal to 0, meaning that y must be equal to 5, right, from this one. The second line is y minus 3 equal to 0. It means that y will be equal to 3. That is if you take 3 to this side now. Now, to find the middle line, which is the equation of the locus, now you are going to add up the number by saying 5 plus 3, then divide by 2. And 5 plus 3 is 8. 8 over 2 is 4. Now, the line becomes y minus 4 equal to 0. And that is option B. B is correct. So at this point, we are going to call it a quit. But for that, don't forget to like, subscribe, and share.